Next bit, this is about molecular formula. So these are what we call water of crystallization. So they crystallize out as molecules in that crystal structure there. So you have 23 for sodium. There's one sodium there. And then for iodine, you have in the periodic table, you have 127, 1 iodine, plus 16 for 3 oxygen. Hang on. You add together, you do not multiply. There are X amount of water. So there's 2 hydrogen, so 2 times 1 plus 16. Overall mass is 288. So you do 23 plus 127 plus 16 times 3. There's 198 plus 18x equal to 288. 18x equal to, you move the 198 to the other side, you're going to get 90. So x equal to 5. So yeah, there you go. Next bit, the formula mass is 238. The atomic mass of nickel is 59. There's only 1 nickel. There's 2 chlorine, so 35.5 times 2. There's X number of water. Water is going to be 2 times 1 plus 16 times 1. So there's 2 hydrogen and 1 oxygen. But out of all of these, which is 18, there are X number of H2O molecules then. Work that out and you can get 59 plus 35.5 times 2 is 130. Then you're going to get 18x. So 18x is 238 minus 130. X equal to 108 over 18. X equal to 6. And that's what you want. Okay? Section B now. I'm not sure if you learned it that way or another way before, okay? Okay, methane sulfonic acid, CH4SO3, okay? CH4SO3, alright? That was the formula you work out above. The molecular formula, CH4SO3, alright? I need the mass, so I know I need the MR at some point. So I'm going to have 12 plus 4 times 1 plus 32 times 1 plus 16 times 3. I straight away work out the MR because I know I'm dealing something with masses and something with mole calculation. So I'm just working it out, alright? We have solid. Now we want a solution. We want 150 cm cube. We want 0.50 mole per dm cube. Okay, this is solid. What am I talking about? Why do I draw diagram? Because it's easy to see. What do I normally say? Oh, Milo. You know Milo, whatever you call it, cocoa drink, whatever you call it, cocoa drink, Milo, whatever. You have a spoonful of it. You just dissolve it in water. Have you changed the amount of Milo you put in there? Not really, right? All of it go into solution, right? You do not take anything out. You do not add extra. You just add water. So your mole is the same. The mole is the same. That is very important. You do not put in extra thing. You do not take away out anything. You put all of it and dissolve it in water. So the mole is the same. Okay. So the mole of the solid is the same as the mole of the solution. You are just dissolving in water. They are the same. Nothing changed. Yeah. So the mass of the solid over the MR of the solid, which is the solid on the left. On the right, you have 150 cm cube. Convert that to dm cube by dividing by 1000 and multiply by the concentration. So once you convert that to dm cube, that dm cube and that dm cube, because this is per dm cube, they cancel out. This will give you mole of the solution. Okay, so nice and easy then. So 150 times 150 to the power of 10 minus 3 times 0.15 times 96. Bring out the 96, yeah? So 2.16 gram. I check, okay? Calculation, you should double check. And this is 3 significant figures straight away. This is 1, 2, 3. 1, 2, 3. This is exact value. I think I'm okay. I don't need to run up or anything. And this is gram, so I have the quantity there. If the unit is not given, you must give the unit, yeah? Okay, in the titration, this much mole of NaOH is exactly neutralized by this much mole per dm cube or whatever. They give you the mole ratio here. That means you don't need to write the balance equation, yeah? The mole of the acid over the mole of the NaOH is 1:1. From the balance equation, then you say, which balance equation? Well, this one. They tell you the reacting ratio is 1:1, okay? What is the actual amount? The actual volume of acid in cm cube, that means I need to multiply by, maybe it's better if I write down properly. The volume of acid in cm cube, I convert that to dm cube. Volume of acid in cm cube, convert to dm cube. Multiply by the concentration of the acid, but I don't know the concentration of the acid. Oh wait, I do know the concentration of the acid. Strange, right? The question is all part of the question. 0.150 mole per dm cube. Okay, so the top bit is the actual mole of acid. The bottom bit will be the actual mole of sodium hydroxide. From the balance equation given by this statement, the actual reacting ratio, this is what you want to find. Okay, so the volume of the acid required will be 0.00150 divided by that. Oh, I get 10. Your calculator show you 10. Do you want to write down 10? That's the thing you need to think. 1, 2, 3. 3 significant figure. 1, 2, 3. 3 significant figure. Alright? 10.0. 3 significant figure. There are certain things, it comes to decision making. Precision, okay? Happens in practical chemistry, happen in practical biology, happen in practical chemistry. I hope it makes sense to you, alright? So now you need to make 250 cm cube of this much mole per dm cube. You need the mass. So we know that, so basically if we have this much solid, we want a solution. We want 250 cm cube. So I draw a diagram. I like to draw a simple diagram to make me see what is going on. What is the mass? Okay. Going from here to here, I'm just adding water. Just add water. So what is different and what is the same? The mole is the same. The mole of the sulfonic acid is the same. The solid doesn't have concentration, yeah? But whatever amount is here, all of it go into solution, dissolve. So the mole must be the same. All I've done is just add water. Here there's no water. Here there's water. I have a solution. A solution is a mixture. That means in water. Okay? So since the mole is the same, so I can say the mole of the solid is the same as the mole of the solution in 250 cm cube. So the solid is going to be the mass of what I want. And then the MR, well, there's a reason why they ask you for the molecular formula. SO3NH3. SO3NH3. Okay, so work out from your periodic table. 32 plus 16 times 3 plus 14 plus 3 times 1. I got 97. So there's M over 97. That's for the mole of the solid on the left hand side. On the right hand side, I have solution. Cm cube have to convert to dm cube because I'm multiplying by mole per dm cube. So this is now in dm cube, multiply by that in mole per dm cube. This will now give me mole. So if I bring up the 97, so my calculator show me 3.6375 gram. However, you can see that this is 1, 2, 3 significant figure. 1, 2, 3 significant figure. It's not that wise to leave that many significant figure, given the data given was in 3 significant figure. Don't forget the unit, which is already given. So yeah, save name. Another thing which is not wise is to run off straight away without giving it to higher number of significant figure, just in case, you know, for the examiner to see that you do understand that what you're doing and there's a reason why you do this, yeah, not by random choice. Okay, so moving on. Moving on to the next bit. Do they ask you for specific? Yep, that's all. So now you do titration. you titrate NaOH with sulfamic, not sulfuric, sulfamic acid, okay? So they tell you this information. 1 mole reacts with 1 mole. So I can say the mole of sulfamic acid over the mole of the NaOH is just 1:1. This is whatever is given in, they don't give us the equation, but they give us the relationship, all right? Now I'm going to put in the exact amount of sulfamic acid that reacts, the exact amount of NaOH that reacts, okay? So they tell us 0.00250 mole of NaOH. So I put this down there because this is the actual mole of NaOH that reacts, okay? So I want the volume of the acid. If the volume is in cm cube, I have to multiply by 10 to the minus 3 before I multiply by the concentration, because the concentration is in mole per dm cube. So you have to multiply the mole per dm cube by something in dm cube. That's why you convert to 10 to the minus 3, yeah? By dividing by 1000 essentially. Rearrange that, then you find out the volume of acid required, 0.0250 over 10 to the minus 3 times 0.150. And I got 16.6667, and they don't say how many significant figure, but looking at how the data was 3 significant figure there, 1, 2, 3 as well. I'll run it up to 3 significant figure because there is appropriate number of significant figure based on the value given in the question. Alright, next bit is a calculation bit. You want to find the volume of sodium hydroxide required to neutralize the succinic acid. You want your answer to 3 significant figure. If you don't know how to work out significant figure, make sure you do, because it's always going to be a couple of marks in physics, a couple of marks in chemistry, a couple of marks in biology, and a couple of marks in maths. Which means that if you think a couple of marks is not a lot, when you combine them together, that 1 mark might be the difference. Alright? It might be the difference whether you will regret it or you won't regret it. Okay? I'll leave you to think about it. Anyway, so here we have this information, okay, because they give us the volume and the concentration. We are dealing with solution chemistry. Solution chemistry means they are in water. We are dealing with concentration times volume will give you more. Here we do not work out MR, however, because we are not given masses. We are not dealing with gases, so we don't do molar volume of gas, which is 24 dm³ per mole. Here is just a straight away is solution chemistry. You got to think about the scenario, yeah? Okay, so we just have NaOH. What I'm going to do now is I'm just going to use W.acid, that means the weak acid, okay, because that formula is quite long to write there, but I know what I'm doing and I'm going to show what I'm doing, okay? I like this kind of mole fractions. If you have seen my other video, it's a personal preference. You might not like it, but I tell you what, it will never be wrong and it will teach you some maths as well, yeah, okay? So whatever you do, as long as you can get to the correct answer, you know, some teachers will use reacting ratio, like direct proportion. They all mean the same thing. But have you ever been confused? Have you ever gotten it wrong? You need to think about, why did you get it wrong? What were wrong last time? Okay, what did you do wrong? Okay, can you afford to make that mistake ever again? All right, I'm showing you this one method. I'm not saying that it's the best in the world, but I can never go wrong with it because I'm showing what I know. All right, I work out mole ratio. So N bracket refers to mole of NaOH, mole of weak acid. It does not matter which way around is it, as long as the number there follows the mole. Okay, so here I have the mole of NaOH, which is 2 mole of NaOH, so on top, over the bottom. This is 1 mole of the weak acid. If I have gotten it the other way around, when I use the word equal has a powerful meaning, then it will simply be 1/2. Alright, now what are they equal to? This is from balance equation. I'm going to put in my value based on concentration and volume now, yeah? Okay, so the top is for NaOH. I want the volume of NaOH. Alright, the thing is, I see the unit there is given in cm cube. So I should work in cm cube. So if this volume is in cm cube, I need to multiply by 10 to the power minus 3. You might not have heard of 10 to the power minus 3 before, but I assume this will be in all-level mathematics. It refers to that. So it means you divide by 10 to the 3. It means you divide by 1000. Now I'm sure you know that, okay? That is volume in cm cube, convert to dm cube. Then I need to multiply by concentration, which is 0.0200. The volume in dm cube, when I divide by 1000, multiply by mole per dm cube, is going to give me mole on top. So the units are consistent, the units are correct, okay? That's what I mean by equal, okay? Equal has a very powerful meaning, yeah? So bottom bit is 25 cm cube, convert to dm cube, multiply by the concentration. I don't deal anything with 2:1 or whatever because I already specified here. My mole ratio from the equation, my mole ratio from the actual value. Okay, that's how I can never go wrong. Now make the volume of NaOH the subject. Then I can bring that up. There will be 2 times 25.0 times 10 to the minus 3 times 0.0500. So now it's just a matter of keying things into your calculator and making sure you can key them correctly. Yeah. Okay. People who are good with maths, you would have seen the 10 to the minus 3 and 10 to the minus 3 can cancel each other out. Or you can just put it into your calculator and they will automatically cancel out anyway. So that gives me 125 cm cube exactly. Okay, whole number exact. And 3 significant figure is 1, 2, 3. So this is exactly 3 sig fig already. There's no need to do anything. Okay. All right. Up next.